Lights, please.
Danke, Otto.
The short film was an introduction.
Now, where are those notes? Let's see here. Where are they? Ah, here they are. Now, relations. Whoops.
I think maybe we go back to the film.
Maybe you can help us with the concept of relations.
Otto, roll the film, please.
Now, remember this sequence?
Stop.
He was showing the relationship between the speed of the car and the distance it took to stop. Notice that at 10 miles per hour it took 7 feet to stop. At 20 miles per hour it took 15 feet, and at 30 miles per hour it took 25 feet.
Otto, transfer the chart to the blackboard. Now that we have the numbers here, let's squeeze them a little bit. Insert a comma so as not to confuse the two numbers. Place parentheses around the pair so as not to confuse one pair from another. And that is an ordered pair.
Ordered because the first element is always the speed and the second element is always the distance.
Remember the crazy kid with the cookies? Squeeze, comma, parentheses. More ordered pairs.
Notice the order. See how each cookie corresponds to a taste. Cookie, taste. Cookie, taste. Cookie, taste.
And the strange basketball game.
Squeeze,
comma, parentheses. More ordered pairs.
And the order is important. Always the name is the first and the number of points is always the second. If they were all mixed up with the name first in this pair and the second in this pair, it becomes all screwy and unordered. And that's no longer any sense to the whole mess.
Fix the order, Otto.
Danke.
Now, this whole group of ordered pairs here is called a relation. This is a relation because it has ordered pairs, and these ordered pairs point out a relationship. In this case, the pairs point out the relation between the name of the player and the number of points he made. To put it another way, a relation is a set of ordered pairs. We go back to the cookies and the speed and the stopping distance. All these sets of ordered pairs are relations. Another way to look at this relation is this. If R is a relation, then it has a domain. And this domain is a set. If R is a relation, then it also has a range. And this range is a set. The domain and range can be sets of anything. They can be sets of numbers, of letters, of cows, of trees, of two-legged float finders, just as long as they are sets. Now, for each element in the domain, there corresponds at least one element in the range. This togetherness forms a new set, R, which is a relation. And every element in this new set R is a pair, an ordered pair, where the first element comes from the domain, and the second element comes from the range, and the bond that ties them together is called the rule of correspondence. For example, speed and stopping distance. Cookies. Basketball. Once I have this set called a relation, how do I communicate its contents?
There are 3 ways. The first way is called raster form. It's a sort of list of ordered pairs, each pair shown, and becomes very easy to find which elements in the domain correspond to which elements in the range because they share parentheses. The second way is called the graph. The graph is plotted on the Cartesian plane. To locate a point on the plane requires an ordered pair, where each element in this pair represents a signed distance of the point from one of the 2 axes. That one picture is worth a lot. With a couple of quick peeks, you can pick up the domain, the range, and the rule of correspondence. The third way is set notation. This is a lightweight and compact way to describe a relation. It is most useful in determining whether or not a pair is a member of the relation. The most admirable characteristic of set notation is its ability to compress an infinite set of ordered pairs into a small statement. You have one question on your mind? You want to ask what good are relations? They are good for describing whatever world you live in.